All right, IM3 classes. Today, we are still working on the binomial theorem. So expanding binomials using Pascal's triangle to make that easier for us. The only difference today is we are going to be adding numbers into it instead of just having two variables. So first example, x plus 4 to the fourth. So what we want to do is we're going to go to the fourth row of Pascal's triangle. I'm going to write this out real quick. 1, 3, 3, 1, and then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And so I'm going to use the fourth row. So 1, 4, 6, 4, 1. Each number in here is going to get an x. So x, 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 and then each number is going to get a 4. 4, I should say each term, 4, 4, 4, 4. And now we do the exponents. The exponents start at, for the x, start at 4 and then go down. So 4, 3, 2, 1, 0. And then on the 4, the second number or the variable in there, if it was a variable, the variable, but on the 4, it's going to start at 0 and count up. 1, 0, 1, 2, 3, 4. All right. So from here, you just need to simplify everything. So we have the basic setup done. You just need to, because we have numbers here that are multiplied, we need to multiply all this out to simplify it. So first thing, I'll just do them each. So this is going to be 1 times x to the fourth times 4 to the 0 is 1. We have 4 times x cubed, 4 to the first is 4. 6 x squared, 4 squared is 16. 4 x to the first, you don't really need the 1 there. 4 cubed is 64. And then 1 x to the 0 is 1 times 4 to the fourth is 256, I believe. I'm going to check that on the calculator. 4 to the fourth is 256. Yeah. So now I need to multiply all these out. So 1 times x to the fourth times. Let me back up a second. I'm just going to multiply here. 1 times 1 is 1 times x to the fourth. That's just going to be x to the fourth. You can put a 1 in front of it if it makes you feel better, but it's not necessary. 4 times 4 is 16, x to the third. 6 times 16 is 96, x squared. 4 times 64 is 256, x, and then 1 times 1 times 1 is 256. And then the last thing we need to do is put in plus, since it's all it's plus here. These are all just going to be positive. So plus, 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 and we are done. Let's look at an example with a negative. All right, so x minus 2 to the fifth. So I got to do the fifth row of Pascal's triangle. So 1 plus 1 is 2. 1, and then 1 on the outside. 1 plus 2 is 3. 3 plus 2 is, or 2 plus 1 is 3 here. Then 1 plus 3 is 4. 3 plus 3 is 6. 1 plus 3 is 4. 1, and then 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 6, or 6 plus 4 is 10. 4 plus 1 is 5. All right, so fifth row, I'm going to write that out, give myself space. 1, 5, 10, 10, 5, 1. Each term is going to get an x. All right, and I'm going to simplify this a little bit. I'm going to take care of the negative at the very end. So here, each term is going to get a 2. I'm just going to make it a positive. So we'll deal with the negative at the very end. Exponents, so it's the 5th power. So these are the x are gonna start at 5 and then count down. 4, 3, 2, 1, 0. And then the 2 is gonna start at 0 and count up. The exponents on the 2, I should say. Now we have the basic outline of it. We just need to multiply things out and simplify. So I have 1x to the 5th times 2 to the 0 power is 1. 5x to the 4th, 2 to the 1st power is 2. 10x cubed, 2 squared is 4. 10 yx squared, 2 to the 3rd power is 8. And 5x to the 1st, so I can just leave there. 2 to the 4th power is 16. And then 1x to the 0 is 1. 2 to the 5th is 32. Multiply everything out. 1 times 1 is 1, so that's just x to the 5th. 5 times 2 is 10. X to the 4th. 10 times 4 is 40. X cubed. 10 times 8 is 80. I don't know why I wrote 10. 80 x squared. 5 times 16 is 80 x. Then 1 times 32 is 32. Last thing I need to do is take care of positives and negatives. So if you remember from the lesson from yesterday, the last one, when it's a minus in here, the terms are going to alternate minus, plus, minus, plus. It's always going to start, the first one's going to be positive, then it's going to go minus, plus, minus, plus, minus. And there we are done. All right, let's look at an example when the x has a coefficient. I'm actually going to change this to something a little trickier. We'll do 2 again. 1's going to be a little too easy. So 3x minus 2 to the 6th. I have to go to the 6th row. So do that real quick. So 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So it's 1, 1 plus 5 is 6. 5 plus 10 is 16. 10 plus 10 is 20. Not 16, 15. 10 plus 5 is 15. 5 plus 1 is 6. 1. So I'm going to write out those for my coefficients. 1, 6, 15, 20, 15, 6, 1. So this time each term is going to get a 3x. I'm going to put it in parentheses. And then each term is a 2. Again, I'm going to take care of the minus at the end. So each term gets a 2. All right, so put in the exponents. So on the first part, it's going to go 6, 5, 4, 3, 2, 1, 0. And then here it's going to start 0, 1, 2, 3, 4, 5, 6. All right, so when for the 3x, this is going to be 3. So let me start back up. So it's going to be 1 times 3 to the 6. Let me use a calculator on that. 3 to the 6 is 729. X to the 6. 2 to the 0 is just 1. All right, so I have to do that for each of them. So it's going to be 6 times 3 to the 5th is 243. X to the 5th times 2. And I have 15. 3 to the 4th is 81. So 15 times 81, x to the 4th times 2. 2 squared is 4. So then I have 20. 3 to the 3rd is 27 times x cubed times 8. 2 squared is, or 2 to the cubed is 8. And then this is 15 times 3 squared is 9. X squared 2 to the 4th is 16. And then this is going to be 6 times 3x. 3 to the 1st is 3, x to the 1st times 2 to the 5th is 32. And then the last one, 3x to the 0 power is 1. And then 2 to the 6th is 64. So now we need to multiply everything out. So 1 times 729 times 1, that's going to be 729 x to the 6. 6 times 243 times 2 is 1,916 x to the 5th. I'm going to do 15 times 81 times 4 is 4,860 x to the 4th. And 20 times 27 times 8 is 4,320 x to the 3rd. And 15 times 9 times 16 is 2,160 x squared. And then 6 times 3 times 32, 6 times 3 times 32 is 576 x. And then 1 times 1 times 64 is 64. And then the last step, since it's negative, it's going to alternate minus, plus, minus, plus, minus, plus. So the first term is always going to end up being positive, and it's going to start minus, plus, minus, plus, minus, plus. Done. All right, so that is what we're doing. If you're expanding the whole thing. The last thing that we're going to talk about is what to do if you're not expanding. So a few of the problems are just going to ask for a specific term or a specific coefficient. So for example, this first one was the first term, an expansion of v plus 3 to the 5th. So to the 5th power, I need the 5th row of Pascal's triangle. That's 1, 5, 10, 10, 5, 1. I'm not going to write out the whole triangle again. I've already done that. It's less than, so 1, 5, 10, 10, 5, 1. I just want the first term. So I don't actually need to write everything out. I'm just going to, there's going to be a V, and then there's going to be a 3. All right, you can put in all the V's if you want, if it makes you feel any better, but I'm just concerned with this first term. So the exponents here start at 5 and then count up on the V's, and then on the 3 it's going to start at 0, go down. All right, so here I just need to work this out. That's 1 times V to the 5th, 3 to the 0 power is 1. So that all simplifies to just V to the 5th is the first term. That's it. That's pretty simple when it's the first term. But let's look at something like to the 7th term. So here I need, I actually am going to write out the whole thing because I don't know the 7th term off the top of my head. So 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, then 1, 6, 15, 20, 15, 6, 1, and then 1, 7, 6 plus 15 is 21, 15 plus 20 is 35, 20 plus 15 is 35, 15 plus 6 is 21, 7, 1. So, and I'm looking for the 6th term. So 1, 7, 21, 35, 35, 21, 7, 1. So I'm going to give each term an X. 1, 2, 3, 4, 5, 6, 7, and then each term gets the 2. I'm just going to do this because I'm going to have to count up. That's just how my brain is going to work for me. So I'm going to do this whole first part, but then I'm only going to simplify the one term that I need. All right. So then I'm going to go to, so this starts at 7, 6, 5, 4, 3, 2, 1, 0. And you start at 0, 1, 2, 3, 4, 5, 6, 7. So we want the 6th term. So 1, 2, 3, 4, 5, 6. So I just need to simplify this term. So 21 x squared times 2 to the 5th is 32. So 21 times 32 is 672. So 672 x squared. Done. All right. The other things I might ask for is what's the coefficient. So if it's asking for the coefficient, all it's asking for is the number in front of the variable, and that's it. That's the only difference. So you're either finding a term or a coefficient. Actually, let's just do one more. I'm not going to do a term. Coefficient. What's the coefficient of m to the 5th in m plus 2 squared? So to the 7th. So again, we need to, it was 1, 7, 15, no, 1, 7, 21, 35, 21, 7, 1, I believe. So 1, 2, 3, 4, 5, 6. I'm missing something, aren't I? Are the 235s? Yes, there are 235s. That would have been a mistake. So 1, 7, 21, 35. So I'm just using the same I'm using the same row that we just used, trying to fit it all in there. There's a lot in here, so it's an M. So M, 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 and then 2, 2, 2, 2, 2, 2, 2, and we'll worry about that. That's fine right there. But the M starts at 7. So 7, 6, 5, 4. That's actually, I'm looking for M to the 5th. So I can stop right there. These start 0, 0, 1, 2. So I just need to worry about this here. All right, so I'm going to simplify that one because that's the m to the fifth. So that's going to be 21 times m to the fifth, 2 squared is 4. So 21 times 4 is 84. So the answer, the coefficient on m to the fifth is 84. That's all it's looking for. All right, so that'll do it for this lesson. If you have any questions, make sure you let me know. Other than that, we will see you guys next time.